Hello students, myself Vidyulata, working as an assistant professor in CSE department in Vignan's deemed to be University. So today we are going to learn about graphs. So here in graphs, so where we are going to use these types of graphs means in path finding. So whenever we are using a network to find a path, shortest path, we are going to prefer these graphs. And we have some more examples like applications using graphs. So these are the applications we have. In case of computer networks, we can use graphs to find the shortest path from one node to another node, and then distinguish between two chemical compounds with the same molecular formula but different structures. So in that case also we can use, and to solve shortest path problems between cities. So finding the shortest route to move to the destination place, and then scheduling exams and assign channels to television stations. So here no two stations should not use the same. So here suppose if you want to schedule an exam, no two days will have the same exam, or no two students will have the same exam on the same day. Before going to the terminology of graphs, we will discuss about the definition of graphs and what are the terminologies we have in graphs. So here how we are going to define a graph means a graph will be represented as G equal to V comma E, where G indicates graph, V indicates vertices, E indicates edges. So here this is a representation, and it consists of a V, that is a set of vertices, those are non-empty set of vertices, and E set of edges. So a graph will consist of vertices and edges. Next, each edge has either one or two vertices associated with it. So how we are going to connect two vertices? With an edge. So here that's why we call those as end points. So we are connecting two vertices with an edge. For that edge, those two nodes are called as end points. Next, an edge is said to connect its endpoints. That's why since we are connecting two vertices with an edge, we call them as endpoints for that particular edge. So here the set of vertices V of a graph G may be represented as an infinite graph or a finite graph. So when we are representing a graph with infiniteness, that means we doesn't know how many number of vertices we have in that particular graph. And here a graph with an infinite vertex set or an infinite number of edges, then we can call it as an infinite graph. Next, a graph with a finite vertex set and a finite edge set, then we call it as a finite graph. That means end is there. So that means suppose if we have taken a graph like this with A, B, C and D. That means we have taken four vertices and we have connected these four vertices with edges like this. So here in this graph we can say that there are four vertices and 1, 2, 3, 4, 5. 5 edges are there. That particular graph is having 4 vertices and 5 edges. That means we can define how many number of vertices and edges are there. But in case of infinite graph, we cannot define how many number of vertices and edges are there in that. So that's why we call it as an infinite graph, and if we can define how many number of vertices and edges are there, we can call it as an finite graph. So here these are the definitions of. So here since based on the edge only we are going to decide, we call those as edge type definitions. So what we are going to discuss means here directed and undirected. So here directed means we are going to specify direction. So how means, see, we have ordered pair of vertices which are represented as u comma v, and between u and v, that is directed from vertex u to v. Since we have the ordered pair u comma v, we are moving from u to v. So that's why we have the vertex u From this we are going to V, and here we are going to specify direction. From U we are moving to represent that. In the same way, in undirected graph, those are having unordered pair of vertices which are represented as U comma V. And here how we are going to move in undirected graph means we can move from U to V or from V to U. Why means we are not specifying any specific direction. So that's why we can move from U to V or from V to U. Since we are not specifying any direction, both way we can move. And next edge type we have is loop. How we are going to specify loop? Means a loop is an edge whose endpoints are equal. If we want to specify a loop at a particular node, we are going to specify itself like this. A particular edge joining a vertex to itself, then we call it as a loop, and the symbol which we are using is this one. Next, here the representation of that is U comma U. That means it is moving to itself. So both starting and ending vertex will be same. That's why we have used U comma U. Next, multiple edges. When it comes to multiple edges, we can say that two or more edges joining the same pair of vertices. That means between two vertices we will have two or more edges like this. Suppose if we have taken a node like A and we have taken a node like B and we have taken a node like C. From this, if we have from A to B we have an edge, and from B to A we have an edge, A to C and B to C. So here if you take this, from A to B we have two edges. So here since it is having more than one edge, or suppose if we take again from C to A also we have. So here for A we have three edges there. So here since they are having multiple edges between two vertices, this is an example how we are going to represent multiple edges. So here multiple edges means two or more edges joining the same pair of vertices. Then we can say it as a multiple edges combination. So before we have seen edge type definitions. Now we will see the graph type definitions. That means different types of graphs available. So what are the different types of graphs available means, first one is a simple graph which is undirected. That means we are not specifying any direction. So how we are going to define means it consists of vertices V which are a non-empty set of vertices, and E edges a set of unordered pairs of distinct elements of V which are called as edges. A graph which consists of vertices and edges. So here how we are going to represent means, here the graph is represented with G of V comma E, and vertices we have taken as U, V, W, and E we have taken like this, edges. So based on that we have taken a graph with U, V, W vertices, and between U comma U and V we have an edge. So we have drawn, and next V comma W we have an edge. From V to W we have drawn, and then from U to W we have drawn. So that means we have connected all the edges based on the edges we have in a example. So what are the vertices we have and what are the edges we have, based on that we have connected a graph. And next, multigraph. In multigraph, why we are saying multigraph? Since it is having multiple edges. See here, a multigraph is a graph that can have more than one edge between a pair of vertices. So since it is having multiple edges, we call that particular graph as multigraph. See here, we have taken vertices and we have taken edges. So based on that, this is an example. So here U we have V, W, and between U and V we have two edges. Multiple edges are available between U and V. Since this particular graph is having multiple edges, we call that graph as multigraph. Next one is pseudograph. So how we are going to call it as a pseudograph means it is also a non-simple graph. That means it is not a simple graph. Simple graph is not having any loops and no multiple edges will be possible. But here in pseudograph there is a possibility of loops and multiple edges. That's why we are saying it as a non-simple graph. It is not a simple graph in which both graph loops and multiple edges are permitted. In this graph we can specify loops and also we can specify multiple edges. So here this is an example. So here in this W is consisting of a self loop. W is consisting of a self loop and between U and V we have a multiple edges. Since it is having loops and multiple edges we call this as a pseudograph. Next graph type is directed graph. So here before we have discussed an edge type. So how we are going to specify edge in case of directed and undirected. Now we are seeing the graph example, directed graph example here. See, in this directed graph we have taken G of V comma E where V is a set of vertices and E is set of edges. And here between these vertices the edges are connected with a direction. See here, from U to V we have specified direction, from V to W arrow is specified in all the edges. That's why we call this as a directed graph. Next one is directed multigraph. So multigraph means, yes, multigraph consists of multiple edges. In the same way this directed multigraph also consists of multiple edges with directions. Before we have seen that multigraph will not consist of any direction. Normally we have specified a multigraph without edges, direction. But here since it is a directed multigraph we are representing edges with directions and we have specified multiple edges and loops also. Next one is mixed graph. In this mixed graph, why we are calling it as a mixed graph means it consists of the combination like both directed and undirected edges will be there. And here that since it is a combination of both directed and undirected we call it as a mixed graph. So here from U to W we have an arrow. That means between U and V we have a direction. But in other edges we doesn't have any arrow. That means we doesn't have any direction. So here mixed graph is a combination of directed and undirected graphs. So here see the table representation. Here in this which graph will have undirected and direct edges we are going to specify in a table format, and which graph allows multiple edges and loops we will see in this particular table. So based on this the simple graph will be only undirected graph. We can represent the simple graph in an undirected way. But here in multiple edges whether it is allowing multiple edges? No. The simple graph will not allow multiple edges and loops. And next multigraph. It is also an undirected edge and it is allowing multiple edges but loops are not allowed. In case of multigraph we can specify an undirected edge with multiple edges but we cannot specify any loops in the multigraph. In case of pseudograph we can use only undirected edge but we can specify multiple edges and also we can specify loops. Already we have discussed that the pseudograph will allow loops and multiple edges. Since it is a simple graph, it is an undirected simple graph. Here in the name itself we have specified that it is a simple directed graph. That means we will specify an edge with direction. So here also it is a simple graph with directed. So simple graph with direction we will specify and we will not specify any multiple edges and loops, since in simple graph no multiple edges and loops are allowed. And here it is a directed multigraph. It is a, since name itself indicating that it is a directed graph. So it is a directed edge type, and here we can allow multiple adjacent loops. Next, mixed graph. We can represent mixed graph in both directed and undirected. In the definition itself, we have seen that mixed graph means it is a combination of directed and undirected. So, we can the edge type is directed and undirected, and here the multiple adjacent loops can be allowed.